So we're reviewing factoring polynomials, and when we start factoring polynomials, the first thing we always look for is a greatest common factor, and we want to see if they have something in common, like can you divide the coefficients by something, or can you take an x out of the problem. The second thing we look for is the difference of perfect squares. This is the kind of problem like x squared minus 81. This is a difference of perfect squares because the word difference in math means subtraction, and there's a minus sign there, and perfect squares means that they're both perfect squares. Well, x squared obviously is a perfect square, and 81 is 9 times 9, so it's a perfect square as well. We're going to do this problem, actually, this is the first problem on your assignment, and we'll get to do this problem in just a second, but this is what a difference of perfect squares look like. And the third method is using the AC method, which works every single time, and we're going to review how to do that and what that method is exactly. So here's our first problem, x squared minus 81, and we have our three steps over here. So the first thing we're always going to look for is a greatest common factor. Well, I can't factor anything out of x squared or 81. They don't have anything in common, so that is out. Step 2, I want to figure out, is it a difference of perfect squares? So remember, difference means I'm subtracting. Perfect squares means that each of these is a perfect square. Well, x squared obviously is a perfect square because it is x times x. 81 is a perfect square because it is 9 times 9. So when we answer this problem, it is x minus 9 and x plus 9. It will always be the case. Every single time we have a difference of perfect squares, our answer will look like this, where we have the minus sign and the plus sign, and then we have the square root of each of the pieces in there. Our formula for this that would probably be helpful to know is that if you have x squared minus a squared, so it's just the difference of two perfect squares, that is equal to x minus a times x plus a. This is just the generic formula for the difference of perfect squares. So problem 2 says 35x to the fifth plus 15x to the third plus 15x. The first thing we're going to do is we're going to look for a GCF, or a greatest common factor. Well, I'm noticing that actually all of my numbers are divisible by 5, so I'm going to prime factor each of these. 35 is 5 times 7, and then there's 5 x's, plus 15, which is 5 times 3, and then there's 3 x's, plus 15, which is again 5 times 3, and then an x. So I'm looking for what they have in common. So notice that they all have a x in there. So I'm going to pull that x out first. They also all have a 5, so I'm also going to be pulling out that 5. And then what is left over is everything I didn't use, and that's what's going to go in parentheses. So I'm going to mark out all the pieces I pulled out, which I'd already highlighted, but I'm going to mark them out. I'm left with 7, and then I have 4 x's, so 7x to the fourth, plus I have 3, and then I have 2 x's, so x squared, plus, and then I have a 3. So that's the first step, is I've figured out that the greatest common factor, so that part's done. The next thing I look for is I look to see, is there a difference of perfect squares? Well, I know it's not a, because difference means subtraction, and there's no subtraction here. Second thing is there's perfect squares. There are no perfect squares in this problem. 7 is not and 3 is not. So there's not a difference of perfect squares. So the next thing I've got to figure out is I have to continue to make sure that this problem can or cannot be factored using the AC method. So what the AC method tells us is the AC method says I need to multiply A and C. So I need to multiply 7 and 3. Well, 7 times 3 is 21. And I need to figure out, I need things that their product is 21, and their sum is 3, and the reason the sum has to be 3 is because this number in the middle is 3. Well, my factors of 21 are 1 and 21, or I could have -1 and -21. Could also have 7 and 3, or I could have -7 and -3. Any of those combinations would multiply to give me a positive 21. Well, then if I find their sums, 1 plus 21 would be 22. -1 plus -21 would be -22. 7 plus 3 would be 10, and -7 plus -3 would be -10. So since none of these gave me a sum of 3, that means that my final answer is going to be 5x times 7x to the fourth plus 3x squared plus 3. This cannot be factored any further. So my next question is number 3, 4x squared minus 25. So first thing I'm looking for is a GCF. I want to figure out, can I divide 4 and 25 by something, which I cannot. So there is no GCF in this problem. Number 2, I've got to figure out, is it a difference, so a subtraction, it has that part, of perfect squares. Well, 4x squared would be 2x times 2x, and 25 is 5 times 5. So this is a difference of perfect squares. So that means that my answer would be 2x plus 5 and 2x minus 5. Remember, when it's a difference of perfect squares, there is always one plus and one minus every single time. I have number 4, 64x squared minus 1. So again, I'm looking for a GCF, a greatest common factor. Well, my 64 and 1, I cannot divide both those by something, so there is no GCF. Number 2, I am looking for a difference of perfect squares. So there's a difference because there's a minus sign in the middle. 64x squared, well, that is 8x times 8x, and 1 is 1 times 1, so this does fit into our difference of perfect squares problem. So that becomes 8x plus 1 and 8x minus 1. For number 5, I have x squared plus 8x plus 12. So again, I'm going to begin by looking for a greatest common factor. Well, I cannot divide x squared, 8x, and 12 by something, so there is no greatest common factor. So I'm second of all looking for a difference of perfect squares. Well, difference means there's subtraction. There's no subtraction in this problem, so this one's out. So the third step I'm going to try is the AC method. So the AC method again says that I need to multiply a times c, which would be 1 times 12. So I need something with their product is 12, because 1 times 12 is 12. And I need the same pair of numbers to have a sum of positive 8, because that's our middle term. So if I start thinking of my product, my factors of 12, I have 1 and 12, or negative 1 and negative 12. I also have 2 and 6, or negative 2 and negative 6. I have 3 and 4, or negative 3 and negative 4. And if I find the sum of each of those pairs, 1 plus 12 is 13, negative 1 plus negative 12 is negative 13, 2 and 6 is 8, negative 2 and negative 6 is negative 8, 3 plus 4 is 7, negative 3 plus negative 4 is negative 7. Now notice that I did have a pair that actually gave me positive 8 like it was supposed to. So that tells me that I'm going to actually use the numbers 2 and 6 to complete my problem. So to complete the problem, I'm going to actually rewrite it. I have x squared plus 8x plus 12, but I'm going to x squared. And then I'm going to use these two numbers that we came up with, the 2 and the 6, and they're both positive, so I'm going to rewrite this as plus 2x plus 6x and then plus 12. So I'm doing what's called splitting the middle term. So I rewrote this, instead of having an 8x, I wrote 2x plus 6x, because if you think about it, 2x plus 6x is 8x. So it's the same problem, it's just written out a little bit differently, but the problem has the same value. So my next step is going to be to group, and then I'm going to factor. So I'm going to group these into two groups, and I'm going to look for what each group has in common. So I have x squared plus 2x. Well, they both have an x in there, and if you need to, you're always welcome to write this out as x squared plus 2x. Notice they both have an x, so I'm going to take that x out, and I am left with x plus 2. I always, without fail, bring down this sign, whatever this sign is, and then I'm going to move over to my next pair that I grouped together, 6x plus 12, and I'm going to prime factor these. Well, 6 is 2 times 3, and then x. 12 is going to be 2 times 2 times 3. I figured that out because I did a factor tree. 12 is 2 times 6, and 6 is 2 times 3. So again, I'm looking for what these two pieces have in common. Well, notice they both have a 2 and a 3, which means they really have a 6 there, because if you multiply 2 times 3, you get 6. And then I'm left with x plus 2. And we know we did this correctly because if you do this step right, you will end up with two parentheses that are identical. So notice both of our parentheses say x plus 2, so that means we did our problem correctly. That means 1/2 of our factor is x plus 2, because that's what we had in the parentheses, and the other half of our factor is going to be x plus 6. And that x plus 6 part comes from what was in front of our parentheses, the x and the plus 6 that was in the front. And that would be our final answer, would be the x plus 2 and x plus 6. Something I want to point out to you guys is notice what my numbers were in my parentheses, positive 2 and positive 6. Those numbers should look familiar because that's the numbers that we came up with over here. Notice my pair of numbers was positive 2 and positive 6. If this coefficient is a 1, if this coefficient of x squared is a 1, then whatever these two numbers are here, it will always be the same as your factorization. So you can skip all of this mess if you want, if this coefficient is a 1. So I have x squared minus 10x minus 24. So again, I'm going to start by looking for a greatest common factor. Well, I cannot divide x squared, 10x, and 24 by something, so there is no GCF, so I'm going to go ahead and mark that out. It doesn't exist. Next thing I'm looking for is a difference of perfect squares. Now, something I want you to remember is the difference of perfect squares always has two terms, and that's it. So if you go back and look at problems like 1 or 3 or 4, they only had two terms, and this one doesn't. It has 3, so it cannot be a difference of perfect squares. So my last thing I try is the AC method. So the AC method says that I multiply my coefficient of x squared, which is 1, and I multiply my c value, which is negative 24. So I'm looking for two things that give me a product of negative 24, and I need those same two things to give me a sum of negative 10, because that middle term is negative 10. So let's start thinking of my factors of 24. Well, negative 1 and 24, or 1 and negative 24. I can also have negative 2 and 12, or 2 and negative 12. I could have negative 3 and 8, or 3 and negative 8, or negative 4 and 6, or 4 and negative 6. That's actually my last set. So then I've got to figure out what their sums are. Well, negative 1 plus 24 is 23. 1 plus negative 24 is negative 23. Negative 2 plus 12 is 10. 2 minus 12 would be negative 10. Negative 3 plus 8 would be 5. 3 minus 8 would be negative 5. Negative 4 plus 6 would be 2. And 4 minus 6 would be negative 2. So remember, I'm looking for the set that gave me negative 10. So that tells me that I am using positive 2 and negative 12 as my numbers to rewrite this problem. So I have my problem, x squared minus 10x minus 24, and I'm going to rewrite it as x squared. And then instead of minus 10x, I'm going to write a plus 2x minus 12x and then minus 24. So again, I did what's called splitting the middle term. So I rewrote negative 10x as two different pieces that still, when I add them together, give me negative 10. And remember, these numbers came from the positive 2 and negative 12 that I got over here when I did my T-chart. So I'm going to group and factor. So I'm going to start with x squared plus 2x. If you need to, you're welcome to write these out as into their prime factorization. So x squared is x times x plus 2x. Well, both of these have an x in there. So if I take that x out, I'm left with x plus 2. So I have x times x plus 2. And then I'm always, always, always going to bring down this middle sign no matter what it is. And then I need to prime factor my 12x and my minus 24. So 12, we did that a second ago, was 2 times 2 times 3, and then x. And then if you were to prime factor 24, well, 24 is 4 and 6, 4 is 2 and 2, and 6 is 2 and 3. So it's really 2 times 2 times 2 times 3. So I'm looking for what these two pieces have in common. Well, they both have a 2. They both have another 2. And they both have a 3. So really that means that they have an 8 in common. Like if I go ahead and 12 in common if I go ahead and multiply all that together. And that's the only thing they have in common, so then what's left over is the x and the 2. That's the two things that weren't in the parentheses. So if I put a minus sign on the outside, then that means the sign on the inside is going to change. Notice this sign was a minus sign, so it's going to become a plus sign. I know that I have done the problem correctly, because if I did it correctly, then my two parentheses are going to be identical, and they are, so that tells me that one half of my answer is going to be x plus 2, and the other half of my answer is x minus 12. I want to point out one more thing that some of you've probably figured out. Remember the numbers that we came up with, 2 and negative 12 here? Well, remember it was a positive 2 and a negative 12. Notice that these numbers that end up in our parentheses are the same as these numbers over here that we came up with that was our pair of numbers that worked. And that if, this is a huge if this coefficient is a 1, if that coefficient is a 1, that's always going to be the case. I have 5x to the third plus 15x, so the first thing I'm going to do is look for a greatest common factor. So I need to figure out if 5x to the third and 15x are both divisible by something. Well, I notice they're both actually divisible by 5, so if I were to prime factor this, 5x to the third is 5 and then 3x's. And then 15 is 3 times 5, and then an x. So I'm looking for what they have in common. Well, they both have a... So problem 8, I have a 14x to the fourth minus 12x to the third. First thing I'm always going to do is look for a greatest common factor. So I notice both these are divisible by 2, so I'm going to go ahead and prime factor this. 14 is going to be 2 times 7, and then 4x's. And then 12 is 2 times 2 times 3, and then 3x's. So again, I'm looking for what they have in common. Well, they both have a 2, so I'm going to take out that 2. They both have 3x's, so x to the third. And if I take out that 2 and that x to the third, I'm left with 7x minus 2 times 3 is 6. So I did step 1, I took care of the GCF. The second thing is I need to figure out if it's a difference of perfect squares. Well, difference tells me there's a subtraction, that's there. Perfect squares means both of these pieces are perfect squares. Well, they're not. This one is 7, it's not a perfect square, and 6 is not a perfect square, so it's not a difference of perfect squares. We just said a second ago the AC method would be used if we have 3 terms. And that means 3 terms in the parentheses. Well, I only have 2 terms in the parentheses, 7x and minus 6, so I can't use the AC method, so this would be my final answer. Number 9, I have 6x squared plus 5x plus 1. So again, I'm looking for a GCF first. I cannot divide 6, 5, and 1 by anything, so there is no greatest common factor. So I'm going to figure out, is it a difference of perfect squares? Well, difference means subtraction. There's no subtraction sign in here. And remember we said difference of perfect squares only works if there is 2 terms, and there are 3 terms in this problem, so it's not a difference of perfect squares. So we're going to try the AC method. So the AC method says that I need to find a product of A and C, which would be 6 times 1, which is 6, and I need to find a sum of 5. So my factors of 6 would be 1 times 6, or negative 1 times negative 6, 2 times 3, or negative 2 times negative 3. That's all my factors there. If I start looking for their sums, 1 plus 6 is 7, negative 1 plus negative 6 is negative 7, 2 plus 3 is 5, negative 2 minus 3 would be negative 5. So that tells me that the pair of numbers I'm actually going to be using is 2 and 3, because they're the numbers that when I multiplied them, they gave me the 6, and when I add them, they give me 5. So this one's a little bit different because it has a leading coefficient of 6 here. So it doesn't change how we do the problem though. So I have 6x squared. Instead of 5x, I'm going to write it as 2x plus 3x. So I'm splitting this middle term, and then I have my plus 1. So I'm going to group, and I'm going to look and see if I have any common factors in each of those groups. Well, if I prime factor each part, because that seems to help. So 6 is 2 times 3, and then there's 2x's plus 2x. And then if I look to see what those two pieces have in common, well, they both have a 2 and an x. So if I take out that 2 and that x, I'm left with 3x plus. Remember, if we get rid of every single thing there, we can't just ignore it or pretend it doesn't exist. We have to put a 1 as a placeholder. I'm going to bring down this plus sign because I always bring down the middle sign. And then I have 3x plus 1. Well, 3x is still 3x, and then 1 is just 1. So notice these two pieces have absolutely nothing in common. If they have nothing in common, we put a 1 there as a placeholder. And I'm left with 3x plus 1. Well, we know we did this problem correctly because notice my parentheses. They're identical. So my answer to this problem would be 2x plus 1 times 3x plus 1. So at problem 10, negative 15x squared plus 21x plus 18. So I'm going to start by looking for a GCF. Well, I'm just kind of glancing at these numbers. I know all of them are divisible by 3, so I'm going to go ahead and prime factor it. So I have negative 15, which is negative 3 times 5, and then 2 x's, plus 21, which is 3 times 7, and then an x, plus 18, which is 3 times 3 times 2. So they all have a 3 in there. So I'm going to pull that 3 out. And I'm actually going to do something a little bit different here because I know that having a negative in front is a really, really, really bad thing. Like, it does not work out well if you have a negative in front. So I'm actually going to go ahead and take that negative sign out. But if I take a negative sign out, then what happens is here, this sign becomes a negative, and here, this sign also becomes a negative. Okay, so anytime I take out a sign, I've just got to change all my signs inside. And that's the only thing they had in common was that 3. So I am left with 5x squared minus 7x minus 6 now. So I took care of my GCF. I need to figure out if it is a difference of perfect squares. Well, we've said difference of perfect squares has 2 pieces, 2 terms. This has 3, so that's out. I need to try the AC method. So I need to find the product, which I want my product to be equal to 5 times negative 6, which is negative 30. And then I need these same 2 numbers to have a sum of negative 7. So my factors of 30 or negative 30 are going to be negative 1 and 30, or 1 and negative 30. I also could have negative 2 and 15, or 2 and negative 15. We have negative 3 and 10, or 3 and negative 10. And 5 and 6, or negative 5 and 6, or 5 and negative 6. And if I find the sum of each of those, I get 29, negative 29, 13, negative 13, 7, negative 7, 1, and negative 1. So notice I did have a set that produced the value that I wanted. I did have a set that produced negative 7. So that means I'm going to be using the numbers positive 3 and negative 10. So I'm going to rewrite the parentheses. I'm not going to rewrite this negative 3. I'll just bring it down and write it as part of my answer in a second. So I have problem 11, which is 15x squared minus 10x minus 25. First thing I'm going to do is look for a GCF, look for a greatest common factor. Well, I notice all of these are divisible by 5. So 15 is 5 times 3, and then there's 2 x's. Minus 10 is 5 times 2, and then an x, and 25 is 5 times 5. So they all have a 5 in common, so if I take that out, I am left with 3x squared minus 2x minus 5. So I took care of the GCF. Difference of perfect squares, I know that is out as a possibility because there is 3 terms in this problem, so that's not an option. So the third thing I'm going to do is the AC method. I need to see if I can factor this any further. So I need to find 2 things that when I get their product, it is 3 times negative 5, which is negative 15. And these same 2 numbers give me a sum of negative 2. So if I start listing my factors of 15, I have negative 1 and 15. I have 1 and negative 15. I also have negative 3 and 5, or 3 and negative 5. And then if I find their sums, then I get 14, negative 14, 2, and negative 2. So I do have a set that works here. I know that my numbers I'm going to be using are positive 3 and negative 5 because that's the ones that gave me a sum of negative 2. So I'm going to rewrite my problem. I'll bring down the 5 in a little bit. I'm going to ignore that for now. So I have 3x squared minus 2x. I'm going to rewrite as a positive 3x and a negative 5x. And then I have that minus 5. Just a reminder, I'm not making these numbers up. These two numbers, the positive 3 and the negative 5, came from what I highlighted over here in pink, positive 3 and negative 5. So I'm going to group and do my factorization. So 3x squared plus 3x. Well, 3x squared is 3xx plus 3x. They both have a 3. And they both have an x, so I'm going to take out the 3 and the x, and I'm left with x plus. Again, I don't just leave a blank spot there. I'm going to put a 1 as a placeholder. I bring down this minus sign, and then I'm going to group and factor the other half. 5x would still be 5x, and then 5, because that cannot factor 5. So I am left, what they have in common is they both have a 5 in them. So if I take out that 5, I'm left with x. There was a minus sign on the inside, but I took out, I brought the minus sign down, so that means I'm going to switch the inside, so it'll be a plus sign. And again, here I got rid of everything, so I'm going to put a 1 there as a placeholder. And I know I did this problem correctly because I have x plus 1 in both of my parentheses. So that means my final factorization is 3x minus 5 and x plus 1, and we cannot forget the 5 that we pulled out earlier in the problem. Number 12, I have 36x squared minus 16. So first thing I'm going to do is look for a GCF. Well, just thinking about this, I know both 36 and 16 are divisible by 2 for sure. So I'm going to go ahead and prime factor both of them. 36 is 2 times 2 times 3 times 3, and then 2 x's. 16 is going to be 2 times 2 times 2 times 2. So what they have in common is they both have 2 2's, so they have 2 times 2, which really means they actually have 4 in common. And then left over I have 3 times 3, which is 9x squared minus 4. So I took care of the GCF, so now I'm going to look to see if there's a difference of perfect squares. And difference of perfect squares means there's a minus sign, which there is. Perfect squares means they're both perfect squares, which they are. So this is going to be a difference of perfect squares. 9x squared is 3 times x, because 9 is 3 times 3, and x is x times x. 4 is 2 times 2. So the way this is going to work, and the way all difference of perfect squares work, is I have a 3x and a 3x and a 2 and a 2, and one time it's a plus and one time it's a minus. So this would be my final answer. In case you're wondering if you ever know when to stop, is if you've tried all the methods and nothing worked, but at this point where it actually would stop on this problem, we don't even have to see if there's an AC method. And the reason we don't have to check for that is or don't do anything else is because there's no squareds left. If there's no exponents of 2 left in the problem, then you're for sure done with your problem. There is no more factorization that you can do. Number 13, I have x squared plus 16. So I'm looking for a GCF. Well, there isn't one because I cannot divide x squared and 16 by something. Difference of perfect squares means there's a subtraction sign in the middle. There is no subtraction sign in this problem. So there is definitely not a difference of perfect squares. And then the AC method, remember we said we had to have 3 terms in order to use this one. And there are only 2 terms in this problem, so this tells us that this problem is prime. It means it cannot be factored, that the smallest form this can be written in is x squared plus 16. And our last problem for the day, 16x to the 4th minus 1. So we're going to look for a GCF. Well, 16 and 1 are not both divisible by something, so there is no GCF. Difference of perfect squares, so difference, subtraction, that's there. Perfect squares, 16x to the 4th is a perfect square, 1 is a perfect square, so sweet, this is a difference of perfect squares. 16x to the 4th is, 16 is 4 times 4, x to the 4th is x squared times x squared. And then 1 is 1 times 1. So that tells us that this answer is 4x plus 1, or 4x squared plus 1, I'm sorry, and 4x squared minus 1. Now notice this problem is different because there's still exponents of 2, so I have to keep going. So I really at this point need to actually start back at the top. And I know the AC method can't be used because neither of these parentheses has 3 terms, and anytime I use the AC method it's because I have 3 terms. So there's still no GCF in this problem, but if you'll notice a difference of perfect squares, I have another one of those. 4x squared minus 1 is a difference of perfect squares because 4 is 2 times 2, and then x is x times x, and 1 is 1 times 1. So this first half, 4x squared plus 1, it's prime. I can't do anything else with it. But 4x squared minus 1 is really 2x minus 1 times 2x plus 1. So I took what was the parentheses 4x squared minus 1, and I broke it down. I factored it even further into 2x minus 1 and 2x plus 1 because each of those was a perfect square.